All right, let's do number 21. Or, I mean, number 20. So, there's a reason why I put these together, folks, because we're really going to be doing the same exact thing. So, I like to put variables first. You know what? It really doesn't matter. So, anyways, a bag of cement that weighs 205 newtons hangs in equilibrium from the three wires as shown in this figure. Two of the wires make a 60 degrees angle and 25 degrees angle with the horizontal. All right, so I think that's, well, they do give it to you, so that's pretty nice. Uh, Assuming that the system is in equilibrium, find the tensions T1, T2, and T3 in the wires. All right, so let's draw the force diagrams. So, so I'm just going to draw it from this point, not from this point, because this point, the weight would have to equal T3. So let's just say that T3 equals the weight. So, so let's say that T3 right here is going to be mg, and they do give the bag of cement weighs 200 or w, or in this case w is going to be 325 newtons because that's given. So this is going to be T3, T2 here, and T1 here, and and I'm gonna kind of draw this, orient this a little bit here, so I can kind of get this as much as possible. So this is going to be theta. T1 is given. Theta 2 is given. We don't. T3 is technically given since we know what the weight is. So it's just this is going to be the theta 2 from the horizontal. Once you apply your geometry rules. So remember, this is going to be the same horizontal length over T1, which you can pretend that this is T1 right here. So this could be T1 as well. So you can treat this as those two angles. So once you get that done, folks, what is it asking? Find the tensions T1, T2, T3. So T3 is going to be the weight. So T3 here is going to be 325 newtons. T2, I don't know how to teach this, to be honest, folks. This is like just a geometry problem more than anything else. So, and apply Newton's laws. So T2 cosine of theta 2, that's this component right here, minus T1 cosine of theta 1. Since it's not moving, that's going to equal 0. And now let's take the T1, so let's take T2, I'm going to call down negative or positive, cosine sine of, so this is going to be T sine of theta 2, T2, minus T1 sine of theta 1. That's going to be equal to 0. So from there, you can, oh my God, I'm so tired. So minus T3 equals 0. All right, so from there, folks, you can, however you guys want to solve it, doesn't really matter. I'm not going to do it here on this video. We're going to presume you guys know your mathematics. Or maybe I guess I'll solve it here. So we're going to solve for T1, T2, and T3s. And we're going to say that T3 is going to be, what was it, 325 newtons? Yeah. So 325 newtons. And let me, so here we're going to solve for T2 on the first equation. So T2 is going to be T1 cosine of theta 1 divided by cosine of theta 2. Remember, folks, these values are given. So, so we're going to replace that with T1 cosine of theta 1 cosine of theta 2. This is going to be plugged in there as a variable. Sine of theta 2 plus t1 sine of theta 1 minus t3 equals 0. So from this, we're going to rewrite this. We're going to clean this variable up a bit. And this is how I chose to solve it. It doesn't really matter. That's why I didn't really want to do this video, because it's, you know, but whatever. So this is going to be tangent of theta 2 plus t1 sine of theta 1 equals t3. So t1 is going to be t3, the weight, divided by cosine of theta 1, tangent of theta 2, plus sine of theta 1. So let's see what those values are. I did check the math, so I'm going to presume this is correct, folks. So so let me rechange this a bit, because they want it into in terms of an identity. So this would be sine of theta 2, and I can already see this, cosine of theta 2. Okay, this makes sense. Okay, so we're going to multiply by cosine of theta 2 on both sides here, and cosine of theta 2. Now, since they have the same denominator, these are added, and that gets flipped into cosine of theta 2. So T1 is going to be T3, the weight, or I'm going to call it mg. I'm going to match it to whatever they have. Cosine of theta 2 times divided by, and this is going to be the identity right here. So this is going to be this is going to be sine of theta 1 plus theta 2. Let's see if that matches, and that should match. So, oh, that definitely matches. Okay. In fact, it matches exactly. Okay. So this would be G right there. So, all right, we're done. I don't know what, I'm already so confused right now. So that's T1. All right, I'm gonna plan these videos a bit better. So T1, so T2 is going to be T1 cosine of theta 1 cosine of theta 2. All right. So cosine of theta 1 cosine of theta 2. So theta 2 cancels on this one. So you'd be left with cosine of theta 1. Oh, that's kind of cool. So they flip-flop. Okay. And that's T2. Okay. So according to this, T3 is going to be the weight, mg. T2 is going to be, I guess this is going to be number 21 here, I guess. T2 is going to be mg times cosine of theta 1 added with the sine of theta 1 plus theta 2. T1 if you guys have any suggestions for how to do these videos, let me know. So I will try and do better. But at the moment, I don't really have much views, so it's kind of hard to motivate myself here. So this is going to be cos of theta 2 over the sine of theta 1 plus theta 2. All right, so I'm going to put mg. I'm going to put 325 divided by sine of those two angles, which is going to be 85 degrees. And I'm going to multiply that by cos of 40 degrees. Or 60 degrees to get, so for this one, Um, theta 1 is 60 degrees. Theta 2 is 25 degrees. Oh my god, what did I put here? Let me change this. Oh no, that was right. So times, I'm just getting mixed up. All right. So for this one, T1 here is going to be 295.68 newtons. T2 here is going to be 163.12 newtons, and T3 is going to be 325 newtons. All right, folks, we're done.